For centuries humanity has looked to the sky for answers, building theories, writing equations, and imagining our place in a grand cosmic puzzle, but all of that, our physics, our cosmology, our understanding of space and time, has just been shaken to its core, because what the James Webb Space Telescope has just seen wasn't supposed to exist. Galaxies, too old planets, too large structures, too perfect, and a signal steady, rhythmic, and unnatural that doesn't fit into any known astrophysical model. This isn't just another discovery, this is a collision between what we believed and what actually is. The James Webb Telescope may have just delivered the most profound warning and invitation in human history, and if it's real, then everything we thought we knew about the universe is. In a series of deep field observations, the James Webb Space Telescope captured some of the most detailed images of the universe ever seen, but beauty wasn't the only thing hidden in those pictures. In the galaxy cluster EL 2744, researchers found perfectly aligned light points, symmetrical structures, forming patterns that don't belong in the chaotic world of galactic evolution. In NGC 1365, a spiral galaxy, unusual motion patterns suggested gravitational behavior that contradicted our most basic models, but it didn't stop there. Similar anomalies began appearing across multiple images. The farther James Webb looked, the stranger the universe became. Patterns repeating across billions of light years, structures showing geometric precision in a cosmos that was supposed to be random. Scientists tried to call it coincidence, but there were too many, too frequent, too perfect, and slowly the whispers began. Maybe we're not seeing randomness at all, but a form of order we simply don't yet understand. Among the many targets of the James Webb Telescope was an exoplanet named HIP 65426b, located hundreds of light years away, and what it revealed left astronomers speechless. This planet is 7 times the mass of Jupiter, orbits its star at 3 times the distance of Neptune, and exists around a star barely 15 million years old. By all known theories of planetary formation, this planet shouldn't exist. There's no visible protoplanetary disk, no leftover material, no gravitational explanation for how such a massive world could form so far out so quickly and remain stable. Some researchers have begun to speculate, what if this planet isn't a product of its current system at all? What if it's a remnant of a previous cycle, a relic from a star system that came before, somehow transplanted, reused, or deliberately placed? For now, there are no answers, just a planet glowing at over 1,000 degrees, suspended in a system that shouldn't have had time to build it. In one of the most surreal discoveries yet, James Webb imaged what's known as an Einstein ring, a gravitational lens caused by a massive foreground galaxy, bending the light of one directly behind it. But this ring located around galaxy J418 isn't just any lens, it's nearly perfect, a full uninterrupted circle of light with such mathematical symmetry that even the most experienced astrophysicists were left stunned. For such an image to exist, the alignment between the two galaxies must be exact, down to fractions of a degree across billions of light years. That's not just rare, that's statistically improbable on a cosmic scale. And while gravitational lensing is a known phenomenon, the degree of perfection here is raising far more questions than answers. Could this be a hint of some deeper symmetry embedded in spacetime itself, a sign that the universe isn't as chaotic as we've assumed, but instead governed by a geometry we've barely begun to perceive? But no discovery has rocked the scientific world like this. The James Webb Telescope has found massive mature galaxies forming just 180 million years after the supposed Big Bang. That may sound far away, but in cosmic terms, that's impossible. According to our current models, galaxies shouldn't have had enough time to grow to these sizes, organize themselves into spiral structures, or produce the brightness Webb has recorded these galaxies are as large as the Milky Way, fully formed and stable, when the universe should have still been a chaotic sea of gas. This has left cosmologists scrambling, because if these galaxies truly are as old as the data suggests, then our entire theory of how the universe began is collapsing. The Big Bang, long treated as the foundation of modern cosmology, may no longer hold, and, as some researchers are now saying openly, we may be looking at a universe that had a history long before our beginning. In a region far from any major galaxy, Webb detected something completely unexpected: a gravitational lens effect. In a patch of space where nothing visible exists, no stars, no galaxies, no black holes, yet light from more distant galaxies bends, curves, and distorts as if something massive is hiding there. Astronomers have tentatively attributed this to dark matter, a form of mass we can't see but which exerts gravitational force. But the precision and intensity of this lensing effect challenge even that theory, because the distortion is too strong, too localized. It behaves not like a diffused cloud of dark matter, but like an object, a structure with defined mass, symmetry, and edges. Could it be a cluster of dark matter condensed into a shape we don't yet understand? Or is this gravitational echo the remnant of something older, something left behind? Some physicists are now quietly floating ideas far more radical that this isn't dark matter at all, but evidence of something built, something ancient and invisible, still warping space in its silence. Among the telescope's most controversial findings is the detection of a massive intergalactic filament, a stretch of galaxies and matter aligned so precisely that it forms a structure over 1 billion light-year long. Scientists have seen filaments before, part of the so-called cosmic web, but this one is different. Its alignment, density, and repeating voids make it resemble a grid, almost like a framework laid across the universe. While mainstream cosmology argues that these patterns are the result of gravitational attraction over billions of years, the symmetry here is hard to ignore. The galaxies follow parallel paths, the dark matter clumps at exact intervals. Even the redshift readings from this region show a wave-like regularity, as if the fabric of the cosmos in this zone was intentionally engineered. Some researchers remain cautious, insisting that our brains are wired to find patterns even where none exist, but others now suggest that if the universe did have a builder, or if intelligence once shaped it, this would be where we'd begin to see the fingerprints in chasing answers to the gravitational anomalies. One proposal has risen from the fringes into serious discussion that dark matter, long believed to be invisible and inert, might actually carry information, not data as we know it, but something deeper, a cosmic memory. In multiple Webb observations, clusters of galaxies formed in arrangements that seem to reflect distant earlier formations, almost like echoes repeating across time and space. What if dark matter, instead of being random, actually preserves traces of past cosmic structures? What if, as the universe expands, this hidden matter holds on to gravitational imprints, shaping future galaxies based on old alignments? It's an idea that blurs the line between physics and philosophy, suggesting that the universe might not only have a beginning, but also a memory. And if that's true, then every spiral, every cluster, every void might be part of a design far older than we imagined. But perhaps the most spine-chilling finding yet is the one few are willing to speak about during a deep field scan. In a void sector, the James Webb Telescope recorded a series of pulses, light fluctuations too regular to be random, too faint to come from any known star. The signals didn't match the frequency of pulsars or quasars. They repeated at exact intervals, then vanished completely. At first, scientists suspected it was an error, a reflection, interference, even a processing glitch. But after running the data through independent systems, the pattern remained The origin point showed no stellar mass. No nebula, no heat signature, just a steady flash precisely timed as if measured or timed. For now, NASA has declined to comment, but behind closed doors researchers are asking a question that has echoed for decades. What if it's a message not meant to be received but simply noticed, and if so, who or what was meant to see it? The James Webb Space Telescope was built to reveal the past, to peel back the layers of time and show us what the universe looked like billions of years ago, but in doing so it may have shown us something even deeper, that we are not just observers of the cosmos, we are part of a system far older, more precise, and more deliberate than we ever imagined. Galaxies that shouldn't exist, planets that defy gravity, signals without sources, structures that mirror intelligence. This isn't random noise. This isn't just science fiction flirting with curiosity. These are data points, real, measurable, undeniable, that challenge the very fabric of our understanding. And if the patterns are real, if the pulses are deliberate, if the universe remembers, then we must confront the most unsettling possibility of all. We have never been alone, not in time, not in space, not even in thought, because what James Webb may have just uncovered is not just a map of the early universe. It may be a message left behind, or a system that was waiting for us to look deeper. And now that we have, the world may never see the stars the same way. So now we ask you, are these discoveries signs of something more, or are we just seeing reflections of our own desire to find meaning in the void? Let us know what you believe in the comments, and if you want to keep exploring the cosmic riddles that the rest of the world is just beginning to notice, subscribe and turn on the notification bell, because the next image from James Webb might not show us where we came from, but where we're meant to go. We'll see you beyond the veil.